Okay, so graphing these polynomial functions, we're going to still do the same things that we did before. We want to find out the zeros, but now we're going to include finding the max and min points and inflection points. In this case, no inflection points, but we're going to use a calculus to find max and min points. So we're still going to do the same thing as before. We need to factor this and find out our zeros. Okay, so I'm going to factor the x out. So f of x is equal to x bracket, and I'm going to factor that 3x squared minus 2. We know that the diagonal equals 6x squared, so we know that it has to add up to positive 5x. So we're going to use positive 6x, negative 1x. Okay, so we're going to have a common factor of 3x here, negative 1 here, x here, and looks like 2 here. So we're going to end up with 3x minus 1, x plus 2. Okay, so then that gives us our zeros. We have 1 at 0. We'll put negative 2 here, and positive 1/3 here. Okay, so those are zeros. X is equal to 0, 1/3, negative 2. Okay, so we're going to go through those 3 points. Looks like the y-intercept 0. That's always good to know because that's an easy point to find. So in this case, there's plus 0 at the end. So now we want to apply some calculus to find max and min points. That means we need a derivative. Okay, so we're going to find the first derivative is 9x squared plus 10x minus 2. This is not factorable, so we need to solve for it using quadratic formula. So I'm going to end up with negative 10 plus minus the square root of 100 minus 4 times a times c all over 2a. So there's our quadratic formula. Solving for that, I get negative 10 plus minus the square root of 172 all over 18. I can factor a common factor of 4 out of there, so it ends up as 2 on the outside. So I'm going to simplify everything by 2. So I end up with square root 43 in here all over 9. So what I did was there's a common factor of 4 in here, which came on the outside, and everything's now divisible by 2. So I get 10 divided by 2, 18 divided by 2, and 2 divided by 2. Okay, so the decimal equivalents for those are approximately 0.17 and negative 1.28. So I'm going to write that down. 0.17 and negative 1.28. Okay, so maybe somewhere around here, negative, so that's going to be the negative version. I'm just going to write that as negative 5 minus square root 43 over 2. And then here, this is going to be negative 5 plus square root 43 over 9. So that was over 9, not over 2. Okay. And so those are going to be the max and min coordinates. So I'm going to write those in. So that's going to be about negative 1.28. So negative 5 minus root 43 over 9. And then there's going to be a point here. Negative 5 plus square root 43 over 9. Okay, those are our zero slopes. We can do our slope tests. So I'm going to test the slopes. I'm just going to plug into my derivative, f prime. I'm going to test a point to the left here at negative 2. When I plug into my slope formula, okay, I'm going to end up with 9 times positive 4 minus 20 minus 2. Well, that's going to be positive. That means I have a positive slope on this side of my 0. Okay, so it's going to go up in this region right here. Okay, it's going to be going up here. Okay, I'm going to test my slope in between these two values here and here. So I'm going to choose a 0. That's going to be a nice easy point to calculate. I'll plug in 0 into here, and I get -2 as my slope. So I know that it's decreasing in this region here. Okay, that's going to end up being my minimum. I'll test one more coordinate. I kind of know that's going up, but I'm just going to test one more. Let's test one at 1. I plug in 1. I'm going to get 9 plus 10 minus 2. Well, that's positive. Okay, so I know that's going to be positive slope. So I'm just plugging into these x coordinates into this slope equation to get this slope chart here. So when I sketch this graph, I have a very clear idea now. I know it's going to go, actually what I'm going to do is I'm not going to calculate the y coordinates, but if these are nicer x values, I would expect you to plug back into the original function to get the y coordinates. But for this one, we'll just avoid that. So I know that's going to go up. It's going to max out at that point there. Okay, right there. It's going to go through the 0. It's going to go down here, and again, I'm going to have a minimum point here, and then keep going like that. So it's following my slope chart here. Okay, and I've indicated the x coordinates of my min and my max. Okay, if the coordinates are a little bit easier to work with, I will probably expect you to plug into the original f of x to get the y positions. So let's take a look at this one here. This one's one that we've never seen before. So this one's fairly familiar to us. Okay, what's new is we're finding the max and min points using our horizontal tangents here. This is a little bit different because we don't really know much about it, but we can still start approaching it the same way. We can still find zeros. We still need to find those. We probably want to find the endpoint behavior. Okay, so let's start with the zeros. So x is equal to 0. We only look at the numerator. Okay, so when is 8x equal to 0 is when x is equal to 0. So it's going to cross the x-axis at 0, 0. That's the only 0 here. There's no vertical asymptotes. I probably want endpoint behavior, so I'm going to take the limit as x goes to -infinity. And it looks like it's going to go to 0. And if I take the limit as x goes to +infinity, same thing. The denominator is going to outgrow the numerator, so it's equal to 0. So we know we have a horizontal asymptote here. Okay, crosses there. We want to find increasing, decreasing regions, which will help us find max and min points. So we need to use a derivative. Okay, so we want f prime. So this is a quotient, so I need to apply quotient rule. So the derivative of the top times the bottom minus the top times the derivative of the bottom, which is 2x. Okay, we can cancel out some common factors here. This is 8x squared minus, this is going to end up being 16x. I'm going to put this together. So I'm going to end up with -8x squared plus 8 all over x squared plus 1 squared. Okay, when I factor out the negative, I'll factor out the -8. So that becomes -8 bracket x squared minus 1 over x squared plus 1 squared. So where the increasing and decreasing regions are going to be found is when I find where this slope is equal to 0. So slope is equal to 0 when x is equal to, when I solve this equation, it's going to be when x is equal to +1 and -1. So at -1, I'm going to have a slope of 0. At +1, I'm going to have a slope of 0. Okay, so I'm going to put that in my slope chart because this is what my slope chart is very useful for. I can test my slope. So if you know what's happening, we probably can guess at what's happening, but in this case, we really haven't seen this before, so I don't really know what's going on in these regions. So I'm going to test. So I'm going to test f prime on the left of, I'm just going to get rid of that, and on this side of -1. So I'm just going to choose a nice number, -2. And I'm going to plug it into my derivative. So I'm going to end up with -2 squared is positive. Positive times negative divided by the denominator here is positive. So I'm going to have negative times positive is negative. So I know that this is a decreasing region. Okay, I've got zero slope here. And then what's going to happen in between 1 and -1? Well, I can test. I'm going to find the f prime at 0. And if I plug in 0 into this equation, I get -1 times negative is positive. Okay, so, and I kind of was expecting that to change from negative to positive. Okay, so there it is. I've got my zero slope, my horizontal tangent here. So that looks like to me that's going to be a minimum by looking at the slope chart, because it looks like it's going to go down. And that looks like a maximum because it's going up. I'm just going to complete my slope chart here. I expect it to be negative slope over here, but let's just double check. Plug in +2. I'm going to get positive times negative in the numerator. Well, that's negative. Yeah, I get negative slope. Okay. So I can use this slope chart then to kind of, and all the information I've got here to kind of draw it. So I can't draw it like this, because there's an asymptote there. But I do know it goes through the middle. There's a 0 here, so I know it goes through, like, I can't cross here because there's no 0 here and it's an asymptote. Okay, so knowing that, I can just kind of adjust my drawing here. I know that it's got to go like this. Okay, at -1, there's going to be a minimum point. It's going to cross through here. At +1, there's going to be a maximum point, and then it's going to go down to the asymptotes. There it is. Okay, so that's what the graph's going to look like. Okay, so using all that information, the asymptote, the 0, the maximum, there it is. I do want to find out where the y-coordinate is. This is a nice y-coordinate. So when x is 1, y is equal to, I plug it back into my original equation, 8 divided by 2 is going to be 4. So that's going to be at y equals 4. When x is equal to -1, I plug it in again, -8 divided by -1 squared plus 1, that's 2, so that's going to be -4. So then that coordinate has going to have a coordinate of -4. Okay, so there it is.